Okay, after discussing about the formulae on relationship between the moments about arbitrary point and mean and the reverse of it, there's a one-stop solution, one problem for all for finding the moments and what the reason behind why you're finding such hectic, lengthy expressions of moments and all that. You will understand. This problem would be a one-stop solution to finding moments. Okay, why we are finding moments or how we are finding moments also. This is a one-stop solution. Now you're being given 4 moments about an arbitrary point. Okay, about A, they are being given. So I'll be denoting these movements with the mu1 prime, mu2 prime, mu3 prime, and mu4 prime. Obviously, guys, if moments about mean are being given, I know first moment would be 0, right? So it would be mu1, no prime will be there, and mu1 would be 0. But here mu1 is being given. So it's definitely my, what you are being given is, it's definitely my mu1 prime, which is minus 15. What is mu2 prime? It is 17. What is mu3 prime? It is minus 30. What is mu4 prime? It is 108. Okay. Yeah, these are all things you are being given. Okay. What you're being asked to find is moments about mean you are being asked to find. Okay. So obviously you should know the relationship between the moments about arbitrary point and moments about mean. Okay. Now, one thing that I know is mu1 prime, expressions are very huge. For mu2 prime, mu3 prime, and mu4 prime, expressions are very huge. Okay. To start with, the first thing that I'll do is, what's the arbitrary point that's been given? A value is given to me as a 4. Now, one more thing that I know is, mu1 prime is nothing but x bar minus A. I know A. Okay. So mu1 prime also I know, from which I'll be estimating x bar because I want the moments about the mean x bar. Okay. Right. So let's see here what you will get. Mu1 prime is what? Minus 15. Arbitrary point is what? 4. Okay. Arbitrary point is what? 4. So what would be my x bar, guys? X bar is nothing but minus 15 plus 4. Okay, minus 15 plus 4. No, this is not 15, by the way. This is 1.5. I'm sorry. This is 1.5 minus 1.5 plus 4. So this would give me what? 2.5. Okay, I'm so sorry. X bar, the mean is what? 2.5. Now, to find the moments about mean, first moment anyways, I know that it is 0, as I was making a mention of it earlier. Okay, yeah, let's see this. First, let me write moments about x is equal to x bar. Okay, that is nothing but the mean. Yes, yeah. So mu1 is what? First moment is 0. Second moment formula I ought to remember, but just try to see, guys. Mu2 only will be there. 2C0 mu2 will be there, right? Mu2 prime will be there. Okay, minus mu1 prime whole square. You can see every suffix is 2. Of course, LHS will be the moment about mean, which doesn't have a prime. RHS will be about RHS will be moment about arbitrary point, which will have a prime. Of course, for this relationship, I have seen there's a plus minus alternative signs. And then the binomial coefficient to change. Instead of 1 to 1, I'll be having different things. Okay, 1 to only I'll be having. Or instead of 14641, I'll be having 1463 only I'll be having, because that 4 and 1 will have some relation and then they'll be simplified further. Okay, if you understand it, it's fine. Otherwise, there's no other option to other than to remember. 17 minus mu1 prime. Mu1 prime is given to me as mu1 prime is given to me as 1.5, right? So I'll be squaring 1.5 minus 1.5. Yeah, right. Mu2 prime is given to me as 17. So what you can use the calculator and get the answer without, please do carry your calculators. Otherwise, it's difficult to do this calculation. So I'll be having 14.75 to be mu2. I'm sorry. This is mu2. Suffix I've written mu3. Coming to mu3. Mu3 is what? Mu3 will be mu3 prime minus 3 mu2 squared mu1 prime. Okay, suffixes will be 3 again. plus instead of 3 and 1, 3 and 1 gets simplified to 2 mu1 prime whole cube. Again, if you add the suffixes, it would be 3. Okay, so mu3 prime is being given to me to be minus 30 minus mu2 squared. Mu2 squared, I've got it. I have been given mu2 prime squared. I've been, this is what I'm doing. Not squared. This is mu2 prime. Okay, say 3 into 17. Mu1 prime is what? Minus 1.5. And then plus 2 into minus 1.5 whole cube. Okay, so finally the answer would be 39.75. Mu3 would be what? 39.75. Okay, mu4. What's mu4? Mu4 prime. Okay, minus 4 mu1 prime mu2 prime plus 6 mu1 prime whole squared mu2 prime minus. Instead of 6, 4, 1, 4 and 1 gets simplified to minus 3 mu1 prime whole power 4. Binomial coefficients now with a plus minus sign, they get simplified. So mu4 prime is given to me as 108 minus 4 into minus 1.5 minus 30 plus 6 into minus 1.5 whole squared 17 minus 3 into minus 1.5 whole power 4. Okay, so I'll be having this value to be, definitely use a calculator, please. Do carry your calculator. 142.32 would be mu4. All the 4 moments about the mean are, I have got. Just highlight them, otherwise write all of them at one place. Okay, yeah. Mu1 prime anyways is 0. Now again, I am being asked the beta 1 and beta 2. What are beta 1 and beta 2? You know, guys. If beta 1 is greater than something, beta 2 is less than something, I'll be, no, not exactly beta 1. It's all about beta 2. If beta 2 is greater than 2, less than 2, I'll be deciding about the curtices of a curve. Curtices is nothing but the peakedness of the curve. I'll be deciding depending on the value of beta 2. Again, skewness also is being decided. Okay. Yeah, let me write the formula for beta 1 and beta 2. That's why I said this problem is a one-stop solution to all the things that are related with moments. Okay. What is beta 1? The formula is very easy to remember. What that is beta 1 is mu2 squared by mu2 squared, mu3 squared by, just a second, mu3 squared by mu2 cube. Mu3 squared by mu2 cube. Beta 1 is that. Okay. What's beta 2? Just see here. Mu4 by mu2 squared. Okay. Just try to remember. There are certain things which are mu3. Obviously, mu3 will be bigger. Mu3 will be in the numerator. Mu3 power 2 and it's like ulta. Mu2 power 3. Beta 2 is mu4. Mu4 is split as mu2 square. Like that you can remember. Okay. If you put those values, mu3 cube, mu2 mu3 square, mu2 cube and all those, beta 1 turns out to be 0.49 and beta 2 turns out to be 0.65. Okay, you can just check, put the values that we have calculated just now and check. In terms of moments about mean only, we'll be calculating beta 1 and beta 2. Okay, now guys, apart from this, there's one more question in the problem which is very simple but then looks like a different one. What that is this? Moments about origin. Anyways, I know that what will be the rth moment formula, either for moment about arbitrary point or moment about origin, I know. Okay. Now, if it is rth moment about arbitrary point, if I take, it is mu r prime is equal to 1 by n summation fi xi minus a power r is what I should be taking. Now, it is asked about origin. Origin is all, let me take A to be 0. My job will be easy. Or A to be 0 I can take. Or just see here, there's one more formula that I've written just in the beginning of calculating moments. That is, mu1 prime is equal to x bar minus A is what I have written. Yes or no? Now in the place of A, if I put 0, x bar and mu1 prime both are same. That means what? The first moment about arbitrary point, that is origin, is nothing but the mean. Okay, just see here. I will rewrite, you will understand. Moments about origin. Moments about origin. What that is in the formula mu1 prime is equal to x bar minus A. Put A is equal to 0. If it is about some point, I'll put A value. A is 0 if I put. Okay, so x bar would be what? Mu1 prime only. So what will I get mu1 prime to be? Already I had calculated x bar now, which turned out to be 2.5. Here I'll be using it. I've already calculated. Now coming to mu2 prime. Mu2 prime is nothing but mu2 plus mu1 prime squared. Mu1 prime is 2.5. 2.5 squared. Mu2 I already have calculated here in the above. Okay, it is 14.75. So that's how I'll be getting mu2 prime to be 21. Okay, moments about origin I am calculating. Mu3 prime is nothing but mu3 plus 3 mu1 prime mu2 plus mu1 prime whole cube. So mu1 prime whole cube I have already calculated, which is 2.5 whole cube. About origin na. So it is, and then here it is 3 into 2.5. Mu2 I have already calculated, which is 14.5, 14.75, 14.75, yeah. Plus mu3 is nothing but 39.75. That also I have calculated in moments about mean. Okay, this turns out to be 166. Similarly, I'll be using the arbitrary point formula to calculate mu4 as well, the fourth moment. That is what? Mu4 plus 4 mu3 prime, mu1 prime, 6 mu2 prime, mu1 prime squared, plus mu1 prime whole power 4. So this turns out to be, this value I'll be calculating. It turns out to be 1132. 1132. Okay? Yes. Now moments about x is equal to A. How will I calculate? That's very easy, right? Already I have calculated about x is equal to 4. Last thing is about x is equal to 2. What is it? Mu1 prime is equal to x bar minus 2. Already I have calculated x bar things and all. Okay. X bar is what? 2.5. Minus 2 is nothing but 0.5. So mu1 prime is 0.5. Accordingly, I'll be calculating the remaining ones. Mu1 prime is equal to 0.5. Accordingly, I'll be calculating using the formula mu2 prime as well, which comes out to be 15. Mu3 prime also I'll be calculating, which comes out to be 62. Mu4 prime also I'll be calculating, which comes out to be 244.00275. I can just say 244 only. Okay, this is how I will do moments about anything I'll be able to do. And this problem is a one-stop solution to all. In the next video, probably I'll talk about skewness and kurtosis as well, guys.